How do optimizers train PyTorch AI models? Have you ever wondered how artificial intelligence models learn from data? Today, we will uncover the role of optimizers in training models using PyTorch. Optimizers are essential algorithms that adjust the parameters of an artificial intelligence model to minimize the error between the model's predictions and the actual data during training. They work by iteratively updating the model's weights based on the gradients calculated from the loss function, which measures prediction error. The training process with optimizers follows a series of steps. First, we have the forward pass, where input data is passed through the model to generate predictions. Next comes the loss calculation, where we measure the difference between the predictions and the true labels using a loss function. This helps us understand how well the model is performing. After that, we enter the backward pass. Here, PyTorch computes the gradients of the loss with respect to each model parameter using automatic differentiation. This is a crucial step as it tells us how to adjust the parameters to improve the model's performance. Finally, we reach the parameter update stage, where the optimizer uses these gradients to adjust the model's parameters to reduce the loss. In PyTorch, we create optimizers from the torch.optim package. We specify the model parameters to update and set hyperparameters like the learning rate, which controls the step size of updates. Common optimizers include Stochastic Gradient Descent, Atom, and RMSprop. For instance, Stochastic Gradient Descent updates parameters by moving them in the opposite direction of the gradient scaled by the learning rate. Sometimes, it uses momentum to smooth the updates. A typical training loop involves zeroing existing gradients, performing the forward and backward passes, and then calling the optimizer's step function to update parameters. This cycle repeats over many iterations, known as epochs, to progressively improve the model's accuracy. Optimizers also support advanced features such as learning rate scheduling. This adjusts the learning rate during training for better convergence. Techniques like stochastic weight averaging can also be used to improve generalization. From an application perspective, these optimizers enable models like ChatGPT, DALL-E, and Midjourney to learn complex patterns from large datasets efficiently. However, ethical considerations arise in ensuring that optimization leads to fair and unbiased models. We must avoid overfitting or underfitting, as these issues could affect real-world performance. In summary, optimizers in PyTorch train artificial intelligence models by systematically reducing prediction errors through gradient-based parameter updates. This forms the core mechanism that powers modern machine learning applications.